All right, so our next speaker, Benjamin, him and I got to bond last night because it turns out he was an extra, a very, very far in the background extra of one of my favorite French action movies, Taxi. So that was amazing to find out that I'm with an actual movie star. Benjamin is going to talk about what if our database was a search engine, which I think is a great question to be asking, sort of as some of the sort of vector databases are here, etc. So with that, Benjamin.
Thank you. Hello. So my name is Benjamin Dauvissat. I'm from France, as you can hear it. Maybe cutting this one? Sorry. I'm a software engineer, a podcaster, sometimes speaker, eternal learner, so I learn everything all the time. And obviously not a photo model. I work at Adelean, a French company specialized in search engines. We are integrators for Elasticsearch, OpenSearch, and Solr. We also provide consulting and training. And we developed our own e-commerce and enterprise search solution, and All.site, a collaborative search engine. This talk is an adaptation. It was first given in French at the Elasticon Global by my boss, Lucien Prekop, who talked here yesterday about NLP. Sorry. You can access, if you want to learn French, you can access the video with the QR code. If you look at the database ranking according to dbengines.com, you can see that Elasticsearch is in the 8th position, and it's the first search engine in the list, among many other databases, which are mainly relational, some document key value, and Elasticsearch is the first search engine. There are many types of databases. You can have a relational, basically the first kind of database you can learn at school with SQL. You have key value, and you can store aggregation, key and values, and for fast finding, documents, graph databases, spatial for maps, time series, columns, and search engines. For example, relational databases will be Oracle, MariaDB, MySQL, Postgre. In time series, you would have InfluxDB. On column, you would have HBase or Cassandra. Key value is Redis. Search engine, you have Elasticsearch, Solr, or OpenSearch. Document, you have MongoDB, Couchbase, Databricks, Graph, Neo4j, Spatial, PostGIS, and Aerospike. But what if we think about Elasticsearch as being many kinds of databases? It can be different. It can be all of these types. Is it a search engine? Yes, obviously it is a search engine. It's based on Apache Lucene. It's used in many search engines over the world, in companies, in eShop, and many other usage. For instance, at Adelean, we build over 40 search engines a year since 2010. But we can also think as Elasticsearch as a column database. Yeah, don't mind the reference, just geek humor. Is it column-oriented? Yes, because it's based on Apache Lucene, which is basically document-oriented, but since Lucene version 4.0, there are doc values. And on this part, now you have very good performances on sorting and aggregating in Elasticsearch. Would it be a spatial database? Yes. You can use geographical aggregations to calculate distances. You have geotiles. You can use geopoint, geoshape, and use aggregations on these points. So you can provide maps in Kibana. Kibana is very, very well fitted for using maps. You can create heat maps. You can request on spatial data. Give me all results in this area. It can be a shape, like a polygon. Some distance. I want every result in an area of 5 miles radius from this point. For instance, in my previous job, I used to work for a company putting steam under a city. And when you use steam in conduct, it's very high pressure. And sometimes there are water hammer. So there is a detonation in the pipes. And they needed to know where this water hammer happened. And so I created a heat map of Paris, and they could see if some part of the map was hotter than another one. So this map needed more attention. Is Elasticsearch time series database? For the reference, some may have it. Yes, it can be used as time series because there is data streams. You have the lifecycle policy to handle your data lifecycle. Cold and frozen storage is quite interesting because you can move your data to a slower storage but still have access to it. Runtime fields, and the ability to visualize data. It can be used, for instance, in industry, where you have, for instance, sensors in a factory. You need to store a large amount of data from the sensors, temperature, pressure, things like that. And then you can exploit it through graphs, because some of the existing systems are quite slow in the industry. You can use it with IoT in the 4.0 industry. And then it brings something user-friendly to your data that didn't exist before. Is it a graph database? Yes. It's just this a little part of it, because you can't request for now. You can browse the graph, but you can explore it with the API, and there is a UI in Kibana. So it's the beginning for it, but you can use graph in Elasticsearch and visualize it in Kibana. Can we talk about documents? We can ask Vaughan, for instance, what are documents? But yeah, Elasticsearch is based on JSON documents, so you can store your product. And one thing interesting with Elasticsearch is it stores information about the document, but it also stores the document itself. So you always have access to the whole document. And it indexes the data beside it. And you can perform operations like get, head, put, some stuff like that. Access with API, bulk loading. Is it a key value? Obviously, yes. You can get your document with just the ID. And you can use near real time with this one if you let the unique key managed by the application. You can choose to handle it yourself, but Elasticsearch will do it by itself, and then you can work with a key value database just like a real one. The question, the last one, is it a relational database? Relational can be complicated sometimes. You can use it to act like a relational database, but with some, you have to give up some aspects. Data is no longer normalized. You don't have the column with a specific type. And you give up on relational or functional constraints. But you can also use some stuff like, if we take the artist movie, you can use it like a relational database because you have the actors, you have the genre, the language, stuff like that. You can use SQL in Elasticsearch. It helps you access the data. You don't have to study another requesting language. If you know SQL, you can access your data. There are nested types, request, aggregation. And join types and parent-child can help you to manage your data. When you work on data, there is principle, the ACID principle. Your data must encounter this four principles: atomicity, consistency, isolation, and durability. It's very well fitted in relational databases. In NoSQL databases, it's more difficult because there are no transactions, for instance. So there was the CAP theorem for distributed system. You can have the consistency, the availability, and the partition tolerance. Elasticsearch is more on the AP side of the theorem. You can't have the three elements at the same time, so you have to choose between CA, CP, and AP. Elasticsearch is more on availability and partition tolerance. In reaction to ACID, they created BASE for NoSQL database. It must be basically available, soft state, and eventually consistent. In the end, it will be consistent. Sorry for the mic. Maybe you have heard about NoSQL. It's not there yet, but it's coming, I guess, in the future time. It's the ability to manage large volume like NoSQL, but keeps the transactional aspect. So it's maybe the better of the two worlds. For instance, CockroachDB uses NoSQL. And you can perform some stuff like basic CRUD operation, put, get, post, delete, some stuff like that. When you perform update operations in a NoSQL environment, you have many steps to go through. The Elasticsearch API, the core, and the index will chain everything you do. You update the document through the API, the core handles it. It gets the document, updates it, stores the document in the index, return OK if storing is ended well. Mark the first version of the document as deleted, but never deletes it really. Then return OK to the core returns OK to the API, and then the user have the OK for the second version of the document. We can talk about optimistic locking with that. Because of Lucene, every writing is immutable. So this is why you have to create a new document based on the first one, mark the first one as deleted, and return the second one. how can you handle conflicts for updates? If two people try to update the same document at the same time, you can have a conflict, as there is no transactions, as I said earlier. So maybe, as you can see, you may have errors, so you will have to handle this error on the client side. And your system must then choose how to handle this error. Do you just erase the document that was updated just before you, and the last wins? It's up to you. But each time there is a version conflict, then you are the one who decides on the client side. You can have many options for that. You can ignore the previous version, as I said, and overwrite it. You can perform the update on the current version that was just updated before you, or just cancel the modifications. There is a quick workaround in Elasticsearch, the retry and conflict parameter. You can tell him how many times you will retry the update before giving up. As you may know, nothing is perfect. Elasticsearch may have some weaknesses. It's not really transactional. It's near real-time, not real-time, near real-time. No joins like in SQL. No transactions, no rollbacks. And sometimes, rollbacks can save your life. But it also has many strengths. It has a flexible query API. The scalability is very easy to perform because it's horizontal. You just add a new machine, you add it to the cluster, and then you improve your cluster, and then it's you can adjust to your activity. You can add nodes, remove nodes, and always have what you need exactly. You can perform the aggregations. There is a wide range of usages for Elasticsearch. It is designed for many purposes, like you can perform CM. This is security with Elasticsearch, with some agents. You can store logs and browse through logs. You can use a spatial database, your maps. You can combine everything with the agents that are provided, like the metric bit, file bit, and stuff like that. It allows you to, I would say, to create exactly a fitting application of your need. You create what you need. You can combine every type of database. This is what I meant. You can combine a spatial database with a time series database all in one. And this is one, on my point of view, of the main strengths for Elasticsearch. So I realized now that I was a little stressed, so I speak fast. I may be at the end. Maybe we can have time for questions, because the most important question is, what about you? How do you use Elasticsearch? So if you have questions, please just speak slowly, because I tried to update my English in the plane. I watched Batman versus Superman. Now I know we must save Martha, but besides this, just please, slowly. Thank you. Bonjour. Want to try it in French?
Test, yeah.
Yeah.
Bonjour, Benjamin.
Bonjour.
That's the amount of French, although I could ask the question in French. Thanks for sharing all the knowledge and insights. So I would like to kind of hear maybe your feedback on this one particular Elasticsearch parent-child relationship technique. I think it was one of your bullets.
Yeah.
My applications in e-commerce, we're considering, so we got products, right? Blue shirt of different sizes at different stores, physical locations.
Yeah.
So we basically have this product repeated not only at physical locations, but also sort of repeated across the different sizes, large, medium, etc.
Yeah.
Would you have any insight about how to model that in Elasticsearch? So for example, for the locations, should we have a nested type that would essentially represent?
You can use the parent ID also for that to link two documents. So maybe you can use some stuff like that.
Because what I'm trying to, and I'll pass the microphone back.
Yeah.
What I'm trying to do is kind of reduce a little bit the duplication of data, because of course the blue shirt large and the blue shirt extra large sharing a lot of metadata. So I'm currently looking into nested objects, so I'll finish with my question, sorry. Do you have any tips about performance issues or other type of limitations behind the nested data type specifically?
I know
Thank you.
some times ago Elasticsearch was putting a warning on nested documents. It evolved, but I don't have the right answer for you just right now, but maybe we can talk later with my colleagues who are far more better than me. So we can ask them.
Oh, good. We got another question in here.
Thank you so much for the talk. You talked about Elasticsearch being different kinds of databases.
Yeah.
Would you have some thoughts on Elasticsearch being a vector database? I never heard a mention about that in your references.
It's the trending word at Haystack this year, vector database. But no, we didn't work on this part for now. So we have to study it, but I wouldn't talk about it if I don't know more about it, because telling without knowing is just...
All right, thank you.
I've got one for you.
Yeah.
Have you seen anyone use Elasticsearch as a object store?
Yeah.
I mean, for binary objects? If you've seen anything, has anyone shared any stories about that?
Elasticsearch mainly stores JSON documents, so storing binary objects would be difficult, I guess, and not very optimal, I would say.
Right, okay, all right. Let me check online. Okay, terrific, terrific. Well, thank you very much, Benjamin. Really appreciate it. And yeah, any other questions, come on down. And don't forget, after the session, meeting out front with Erica. So, all right, thank you. Oh, we got one more. Can always count on Stavros.
And sorry for being so fast.
No, please. Oh, making me run. I miss my knees.
Thank you. That's very impressive. I think Elastic can do a fantastic job on many things. Could you just discuss a little bit the differences between Elastic and OpenSearch in all these areas? Because as far as I can tell, they're pretty much identical. Is that fair?
Yeah, Elasticsearch and OpenSearch are binded. There was a fork before that. But for now, I just worked on the Elasticsearch part. I don't know OpenSearch yet. So I'm sorry I can't answer you. I won't tell you bullshit, because that's not what is very intelligent. But I can't answer that for you, but I will study it. It's part of my plan for the day to come.
All right, we got one right here, and then again, one right behind. Excellent.
Thank you for the presentation. I have a question about the terminology, about the title of the presentation. How do you see the difference between being a database and an engine? Search database versus search engine. What's
Because on the many types of databases, search engine is one of them, and Elasticsearch is told as being a search engine. But what I wanted to show with this talk is that you can use it as many other types of databases. It's still a search engine, but it can do other things. And also, search engines are optimized for search, as the name says, and it will be more efficient than, for instance, Oracle database on a large amount of data. I have some examples for that. In France, I worked for an electrical company. They had an Oracle database handling more than 30 billion lines. The Oracle request with about 20 criteria took around, it was on many tables with joins. It was over 1 minute. The same thing on Elasticsearch, less than 1 second. So they went to Elasticsearch after that.
Cool. All right. Bertrand, we got another one? Please.
Benjamin, you mentioned something that kind of caught my attention. So Elasticsearch is a document store, and the original data is stored in, I guess, the source field, right? It's getting a little geeky here. But so that's interesting, because I'm actually trying to remove the source field. Like, I don't want it. Like, what is there a way to do that? Like, I want the meanest and leanest index I can get, and not storing the source field. However, I am interested in retrieving, say, the title, or maybe some kind of timestamp. So a couple fields, right, out of many others. Is there a way to do that?
I would say through pipelines, ingest pipelines. Maybe you can use it to remove a field.
There's a mapping parameter.
Yeah. We have an expert.
I don't want to like steal your thunder, Benjamin. My name is also Benjamin. That's not a joke. It's true. So it's okay.
Benjamin is answering you.
Yeah, it's I don't know any French. Well, you know English. So you can on the index level, you can say don't store the source, and if you are storing the information to be indexed to be queried, you can then use the fields parameter on search, and it'll retrieve it from the doc value. So you can totally do that. And we have people removing source, and it saves you like hundreds of gigs. Like, it's kind of ridiculous. So yeah, so you can keep source off. And we just have something recently, and for time series optimized things, that allows you to synthetically rebuild source. But I think it's only right now for time series focused stuff. But that may be turned on for other things in the future too.
Thank you,
Benjamin,
Ben,
for the help.
Terrific. Any other questions? All right. Thank you, Benjamin.
Thank you.